hyperbolas. Hyperbolas. So, you guys, what hyperbolas are? Is there just ellipses that got broke apart and flipped around? Let me just show you real fast. So we had learned about ellipses. Right? They kind of look like this. Now what a hyperbola is if I halved that ellipse. It's like me breaking the ellipse apart like a egg. It looks like a broken egg. And then I flip it out. Like it is from here to there. Okay, so the information that we will be finding will still be a center point. And we're going to find it the same way we found the ellipse center point. We're still going to find these major vertices. And those will be similar to the way we found the major vertices with ellipses. We're still going to find the foci, but you will notice that the foci, instead of being on the inside when it flips out, they're now on the outside of this figure. It's not a closed figure anymore. And so the formula for finding the foci is different. And then the other value was these like minor vertices. These right here. Well, when I break it apart, they're not there anymore. Because they were connecting the ellipse, but when I break it out, it's not there. But this will be a reference of how wide or how long the space is. You'll see in a moment, but it has to do with the asymptotes that we will be doing. So in the equations, in the first page, in all of that information, there's some new vocabulary terms. There's the transverse axis and the conjugate axis. So the transverse axis is like the major vertices, and the conjugate axis is like the minor vertices. Okay. However, it's not major and minor because the transverse is not always the bigger one. It's not always bigger. Necessarily, is that a word? Necessarily bigger? It's not always the bigger axis. It is whatever comes first. You notice in both formulas, the a squared comes first, where with the ellipses, the a squared might have been first or second. But the a squared always gives you the transverse axis. It always gives you the vertices. And it always comes first. And the b squared always comes second. These equations are a lot like the ellipses, only they have a minus sign in the middle. It still equals 1. And then what's different between these two equations up here is this one starts with x, and that one starts with y. Okay, so all of this is in your notes, so if you forget something that we talked about, you can go look it up in the notes. I told you the foci have different equation to get c squared. Since the ellipse has a minus sign, now the foci have a plus sign. It just switches. I will show you how to do the asymptotes today. We're going to use point-slope formula, but then we're going to change it into slope-intercept form. That's all written here, but I'll show you how to do it with the examples. Okay. So after your quiz last time, you were supposed to maybe start to figure out the center and vertices, maybe foci, but not the asymptotes. We'll do that together. So the center, I'm going to go look up here, but I can't find the center yet because it's not in the right form. So how do I make this in the correct form? Why am I dividing by 37? It has to equal 1. So we get x squared over 9 minus y squared over 4 equals 1. So that's the equation we're going to actually use for all this information. So what is our center? And that's just like it was with the ellipses. Now the vertices, there's only one set of vertices, and they have to do with A. A squared is always first. There's only one set of vertices. A squared is always first, so we are using a squared is 9, so what's A? And then you look and you see that 9, the first thing is under the X. So the 3 goes horizontally. We always go off of our center point, so we would take 0 plus or minus 3, comma 0. I'm going to simplify that. Negative 3, 0, and 3, 0. You could also do it graphically. You start at the center and you go out 3 in both directions. Yes.
So we're just not worrying about the length. I know minor vertices aren't ahead of each other. They do that kind of reference.
Yes. I'm going to do that next. We'll do it. What should we do the first time? I'm going to do, I always do the B next. I always do the B next. So we are going to use B squared, and it's not an actual vertice, but it is a point that we have to graph. So B squared is under Y. What's my B? 2. If it's under Y, then I'll go up and down 2. But it's not an actual vertice that we list. What we do instead with it is we're going to make a rectangle. And this rectangle is going to be up 2, and it's going to be down 2. It's also out 3 to the left and out 3 to the right. So we're using the A and the B to make this rectangle. Rectangle is really not part of the hyperbola. It's just a reference rectangle to help us graph the hyperbola and find the asymptotes. So what we do with this rectangle, we needed to know to go up 2 so we could connect the rectangle. What we do with the rectangle, ooh, I have straight edges. If you don't have your own straight edge, I have some straight edges. Have your own, let me know before I pass them all out.
You don't get hurt.
Okay, so we are going to connect the corners, the diagonal corners of the rectangle, including all the way through the center of the rectangle with our straight edge. And I'm going to do it using a dashed line. I'm going to connect from corner to corner. And it goes through the center of the rectangle. And it's not really there. It's, again, reference, so I dashed it. This is the these are the asymptotes. So we'll find the equations of those in a moment. But those are the asymptotes. Yep. Hyperbola. Yeah. So what asymptotes are, and we've done asymptotes before, is this curve is, so this is my arm's an asymptote. The curve is going to get closer and closer and closer to the asymptote, and eventually it's just going to look like it's running all the way, next to it. It's not going to pass through it. But you got to be careful because some people go close to it and then for some reason they curve away, but it doesn't. It just gets closer and closer and closer to the line. So the vertices that I've done in red, those are the start of my hyperbolas, and I'm going to curve them out along the asymptotes in either direction to make my hyperbolas, or my hyperbola. There. So that's why you need to graph asymptotes first so you know how to draw the hyperbola.
Which ones are the asymptotes?
The diagonal lines that connect them. So we got to make the rectangle so we can draw our diagonal lines. You need the diagonal lines to draw your hyperbola. And the diagonal lines are the asymptotes.
You need all this?
What?
You need all this?
You need all this. So we said? Yeah. Okay, then we need to find the foci. And the foci we're going to use a squared plus b squared equals c squared. That should be easy to remember. So I'm going to do my a squared is 9, plus my b squared is 4. And then to get c, I will square root it. So c is square root of 13. And then the foci go the exact same direction that the vertices went. So since x came first, the foci are also going to be horizontal. We're going to affect the x. So I'm going to have negative square root of 13 comma 0 and square root of 13 comma 0. But to graph that, I need to know what square root of 13 is. We'll just type that in the calculator, approximate it. 3.6. You remember that starts at the center and goes out 3.6. Center, out 3.6. Now the last thing we're going to do is we're going to find the equation of the asymptote. So we're going to use point-slope form. The point that we will use is the center, but we need the slope. Green. Slope, abbreviated M, is the rise over the run. But you could look at the graph and count. But not everybody is a visual person. Some people like formulas. So we think of rise over run, that's also the change or the difference in y over the difference in x. That just means change in y over the change in x. So the change in y is when you look at the equation, it's either a or b, whatever's under the y. So when I look at my y squared and I see 4 underneath it, the change in y is just the square root of that, which is what number? 2. And then the change in x is whatever's under the x squared, the square root of that. So 3. Oh, I just wrote b, I meant to write 2. You could also look at the graph, start at the center, go up 2 over 3, and hit the corner of the rectangle. But there's 2 asymptotes, so it's not just 2 over 3, it's actually plus or minus 2 over 3. There's 2 asymptotes. So it's plus or minus 2 over 3. One goes positive, one goes negative. Same number. So we're going to plug that into point-slope form, which you all have. On that front page. I can't see mine at the same time, so I'm just going to rewrite the equation right here. You don't have to rewrite the formula. It's on your page. That's point-slope formula. So we're going to use the center point, and we're going to use the slope, but since there's 2 slopes, we have to do it twice. So we'll do y minus 0 equals 2/3 x minus 0, and we're going to do y minus 0 equals negative 2/3 x minus 0. I just use my point-slope formula, one for positive, one for negative 2/3. And then we would distribute, and 0 doesn't change anything. We're going to get y equals 2/3 x, and y equals negative 2/3 x. What's our y-intercept for the asymptote? Y equals mx plus b. What is the b? 0. And does that make sense with my graph? Yeah. So you kind of want to make sure that your asymptotes fit the graph, just in case you make a silly mistake. Okay? Do it again. Turn the page. Yes.
So the equation for the asymptote is just take this slope and
You point to the formula
with the sign.
as your point. So you just change it into y equals mx plus b. This one will be a little bit more, you'll see it more because that last one had 0, 0 for the center, but this one goes 0, 0 for the center. All right. A mistake that happens very often. In fact, I did it yesterday. It happens so often that I even made this mistake. Look carefully. We have to find our center. This is in the correct form. But our center is xy. So it needs to be -1, 2. What happens if you have your center wrong? Have the whole thing's wrong, right? So yesterday when I realized I had my center wrong, I had to erase everything. I'd done everything. And the graph. So let's just take our time and look carefully. If y comes first, it's still the y value in the center. Okay, from here, we're going to figure out what our A is. That's how we get our vertices. Our A is 3, because A squared is always the first one. So A is 3. Now, A squared, A is underneath which variable? It's under the y, so we're going to change the y part of the center. We'll keep our x the same. We're going to take 2 plus or minus 3. So I'll get -1, -1, and -1, 5. And then we need to just use our B to draw that rectangle. So what is our B? B is 4. And that's going to be, for this one, it'll be left and right, just 4 units. After we have our rectangle, then we make our asymptotes with the corners from the rectangle.
Wait, how do you get the little rectangle again?
Well, you have to go, you have to use your B value,
That's 4 away.
and it's 4, and since it's under X, it's going to be 4 horizontally away. And then from there, you go straight up and down, and you do side to side from the other vertices. Connect them.
Why does it matter?
What?
I'm confused with the X and Y thing.
About which X and Y thing again?
What? Doesn't X always come first?
No. It did with ellipses. It doesn't with hyperbolas.
Well, okay, so what if Y? Is what X always comes second?
X or Y could be first or second.
So what if X comes first?
If X comes first, like the first example, X came first.
Yeah.
Then my hyperbolas are going this way.
So now they're gonna go up and
It's going to be this way. Yes, Tree.
Is there a way to tell, like, just looking at it, like, the equation between ellipse and a hyperbola?
Yes. And actually, that's what we're doing on Friday, but the minus sign in front is either X squared or Y squared. So that is what we're doing on Friday. For now, they're just going to be all be hyperbolas. Okay, so since I have my rectangle, I have my asymptotes, I'm now going to draw my hyperbolas using my vertices and the asymptotes. Because y came first, that's how I know that my hyperbola opens up and down. Because y came first. Both sides, we use a squared plus b squared, so I'm doing 9 plus 16, which is 25, so my c value is 5. And the foci go the same way the vertices went, so they're going to go up and down. They're going to affect my y values from the center. -1, comma, 2 plus or minus 5. So -1, -3, -1, 7. And then finally, we have our asymptote equation. So we need our slope, and our slope is always y's over x's. The difference in the y's over the difference in the x's. So I look up here, and we'll see what is underneath the y. Underneath the y is 9, so the difference in the y is 3. Underneath the x is 16, so the difference in the x is 4. And we do plus, minus. We do 2 of them. And does that make sense graphically? If I go in the center and I go up 3 over 4, is that on the line up 3 over 4? So you could do it with the graph too. You don't have to use the numbers. You just do the graph. We're going to do our point slope formula. We're going to use our center as the point. So we'll have y minus 2 equals 3/4 x plus 1. And y minus 2 equals -3/4 x plus 1. So the exact same equation, just one is positive 3/4 and one is -3/4. And I encourage you to not type it in your calculator, do fractions, because if you're letting the calculator do all your work, you are not getting smarter. You will be an old person someday who still has the mind of a 17-year-old, hasn't matured their mind because you never did anything on your own. So I'm going to do this by hand.
Wait.
What?
Your equation for m, why did you put 2 equal signs?
I didn't put 2 equal signs.
Is that a plus?
As a plus minus. Yes. That kind of overlaps itself.
Yeah, they kind of looks like it. You cannot.
Well, it's not
I know.
the same part of it.
I know, I wasn't.
So we're going to distribute, I'm going to get y minus 2 equals 3/4 x plus 3/4. Then I have to add 2 to both sides, but I can't add 2 with 3/4. I have to add common denominator. What equals 2 that has a 4 in the denominator? 8/4. So we have y equals 3/4 x plus 11/4. Do the same thing over here. Distribute, and I get -3/4 x minus 3/4. And then I'm going to add 2, which is the same thing as adding 8/4. So I'm still adding the same number both times. You really only have to figure out that fraction once. And I get -3/4 x plus 5/4. And since I am using fractions, and it's easy to make mistakes, I'm going to think about what my y-intercepts are and make sure they make sense with my graph. So with my asymptotes, the equation of my asymptotes, my top one has 11/4, which is like 3 3/4 for a y-intercept. Does it make sense with my graph that one of them has 3 3/4 as a y-intercept? The other one is 5/4. That's 1 1/4. Does that one make sense? Does it look like it's close to 1 1/4? It does on mine. It doesn't look like it on yours. So that's just a check to make sure you're doing it right. Okay. So how about the next one? I haven't changed it. You need me to scroll that down. Oh my god. Somebody in first period. I don't even know. Alright, how about that next one? What should we do? What should we do? We gotta complete the square. This is another thing that people can make mistakes so easily, because now we have this negative sign and it throws things off. Pay attention to details. I'm gonna rearrange the order And I'm going to take out 25 at the same time. If that's confusing anybody, let me know. I don't want to lose any of you.
What is this?
Change. The change in the line. That's what it is. The rise from the line.
So let's just take that.
You just put, well, it's the y. So the y can be that. But whatever's with the y.
Well, why would actually?
It's always y. It's always rise over run. Right? Okay, then I'm going to rearrange. What am I going to take out for y? I'm going to take out -4. So if you take out a -4, that means when I take out a -4 from the positive 24y, it becomes -6y. So if you were to get that sign wrong, you would have your center wrong, which would make everything wrong. Yes.
The number that you have to add to like the y squared minus 6y plus, and then wouldn't you also be taking a -4, the like strengthening number? So,
Well,
that might answer my own question.
did you?
Okay. I figure out.
So what number would I put right here?
Right?
I put 9 here, but then I multiply that by -4, and over here, what do I put? A -36. So that's also another place where people make silly mistakes. They forget to do a minus. Right here, what am I adding in?
25?
A 1, which over here is a 25. So we've got 25 parenthesis x minus 1 squared minus 4 parenthesis y minus 3 squared equals, is it 100? We're just doing complete the square, which we've been practicing for a while. Then what do I have to do? Divide by 100. So when I divide by 100 and I reduce these, I get x minus 1 squared over 4. I still get a minus sign when I reduce it. The bottom number is still a positive 25. Y minus 3 squared over 25 equals 1. So that minus sign is still there when I reduce it. Now can we find the center? What is it? X, then Y. 1/3. And then for our vertices, what comes first? A is what? 2. And since it is underneath the X, I'm changing the X. I'm going to do 1 plus or minus 2 comma 3. Negative 1/3 and 3/3. Question? Then I'm going to go ahead and do my B value just so I can find that rectangle. B would be what? 5. And so, and that's under the Y, so I'm going to go up and down 5. All right, but not dash.
You get the points.
The 5. I went up and down 5. So which way does our hyperbola open? Right, that? Left, right? A pretty wide one. We use a squared plus b squared to find our foci. So a squared, we're going to do 4 plus 25, then we're going to square that, so square root that, so c is square root of 29, which is approximately 5 points. 5 point something. So that means I'm going to go up and down 5.4. From the center. No, I'm not up and down. Left and right, I'm sorry. Left and right, 5.4 from the center. 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5.4. From our center, so we're going to do 1, 1 minus radical 29, comma 3, 1 plus radical 29, comma 3. When it's like wider, the foci are out a lot further. If it's skinnier, the foci are usually in more. And finally, we have the equation of the asymptotes. So we go over how do we find rise over run? The slope. Change in y over the change in x, the rise over the run. So which one of these is y? 5. Over the x, 2. So we're doing plus minus 5 over 2 for our slope. And our ordered pair is 130. We okay? Questions? So I'm doing y minus 3 equals 5 over 2 times x minus 1. And y minus 3 equals 5 over 2 times x, just kidding, minus 5 over 2 times x minus 1. And we'll distribute. I distribute to get 5 halves x minus 5 halves. And then I'm going to add 3, but I have to add some sort of half. So I'm going to add 6 halves. That equals 30. Other side, distribute. Just careful when you distribute with the negative, with the change the sign. Negative 5 halves, x plus 5 halves, and then add 6 halves. And then you should think about your y-intercepts on the graph. Does it look like it hits the graph at a half on the y-axis? Does it look like it hits the graph at a half on the y-axis? The asymptote. Right here at a half? Looks like it to me. Does it look like it hits at 11 halves, which is 5.5? Just to make sure we're doing it right. Okay, so I'm going to stop checking for a little bit, and I want to see if you are understanding this. So I want you to try D. Do your stuff, you can ask questions. I want you to try D. So I'm going to take out the 25 from the x's. And I'm going to take out negative 4 from the y's. And I'm going to move over 196. Then I'm going to add, what am I 4, but that's really like adding 100. And I'm going to add 1, but that's really adding negative 4. Yes, it does. So now, when I simplified it, I get 25 multiplied by x minus 2 squared minus 4 multiplied by y plus 1 squared equals negative 100. And when I divide by that negative 100, that's going to make the center sign into plus. That's going to make the sign over here into minus. So I'm going to switch the order as I'm doing it, because this first one's actually going to be the minus. So I will have x minus 2 squared over, just kidding, I will not have that. Let me totally start over. I will have y plus 1 squared over 25 minus x minus 2 squared over 4 equals 1. So you'll have to switch the order for that one.
So it has to, it just has to be.
The minus sign has to be second. So now I skipped a step. You could have simplified that and realized the first one is the minus sign. And then done another step where you just switch the order. I just did it all in one step. If you are way ahead of me, please feel free to work ahead. Just make sure you have the correct center. The center is x, then y. So my center is going to be 2, negative 1. What's wrong? Why? How you forget this? Square root of 29.
Yeah, but like it's above the point for the bottom.
From the center. That's right. You went from the x-axis, right?
Yeah.
And isn't it 5.4? It's square root of 29. Okay, so my vertices, I will be using 25, so I'm going to be using A as 5, and that is under the y value, so I changed the y. 2, comma, negative 1 plus or minus 5. So I get 2, comma, negative 6, and 2, comma, 4. Scratch graph the center. We use our B value. Our B value is 2. So I'll go out 2 to draw my rectangle. Doing all right? This is just too much fun to handle. Is that what's happening?
Yeah.
We're overwhelmed with all this.
Yeah,
Yeah, after this one, we'll take a break. Okay, so I'm going to draw in my hyperbola. Remember, it gets closer and closer to the asymptote. It does not touch the asymptote and go back. It just gets closer and closer to the asymptote. On my foci by doing square root of 29 for C, and that's going to go vertically. So we'll do 2 comma negative 1 minus square root of 29, and 2 comma negative 1 plus square root of 29. which is about 5.4. To do the asymptotes, we gotta find the change in the y, the change in the x. So we look at our y in the equation and what's under the y. 25, so it's gonna be 5 over what's under the x. 4, so it's gonna be 2. Let's go. 5 over 2 for our slope. Plus minus 5. We'll use our center point. I already forgot. 2, negative 1. Y plus 1 equals 5 halves x minus 2, and y plus 1 equals 5 halves, negative 5 halves x minus 2. You distribute. Y plus 1 equals 5 halves x, and when I multiply 5 halves times negative 2, I get negative 5. So when I subtract 1, I get negative 6.
Are you gonna use this equation in the test?
No.
How do you?
What, point flood form?
Yeah.
Nah, that's from like algebra 1. But I've showed you what you can do if you're desperate. Kind of showed you, which you should totally do for the ACT. No, you don't write it on the calculator. That's not what I'm talking about. Nope, that's not what I'm talking about either.
You put it in your calculator. I have it in mine.
Program software, yeah. Wait, do you have point flood form?
Yeah, I do.
From Emory?
Yeah.
I was looking at Kyler's, he gets super fired. I was looking at his, but I didn't notice that one in there.
Yeah, I have like.
Well, you know, those are there to make you go faster, but it's not gonna like tell you what
No,
you
yeah.
need to do on the question, unfortunately. It's not gonna give you a 36. It's just gonna help you with time. Oh, take a break. I'm gonna pause this. I'll put it back up. You're still copying. Okay, if you are understanding this and you want to work ahead, please go for it. If not, I'm going over it right now. So we need to find 3 pieces of information. The center, a squared, and b squared. That's what we need to find. The center is going to be the middle of the vertices. It's also going to be the middle of the foci. So how do you find the middle point? You use the midpoint formula. You graph it and look at the middle. You can just look at these points and say, what's the middle of negative 10, 3 and positive 10, 3?
0.
0, 3.
But I'm saying negative 10, 10.
So, but the point would be 0, 3, right? So I found my center, and my A value is how far away the vertices are from the center. So I look and see how far away are these vertices from the center. 10, so A squared is 100. I also need to know if it's going vertically or horizontally. So A is negative 10 away, but that's the X that's changing. So this one's going to be horizontal. It's going to tell me when I write the equation, X comes first. X goes with the A, whatever comes first. I start writing the equation. I know X comes first. Oop, I don't need a parenthesis though. And I know A squared is 100. I just have to find B squared. And I'm giving the foci. The foci don't give me B. What do they give me? C. So we got to find C. C is how far the foci is from the center. 12. So C squared is 144. And then we use A squared plus B squared equals C squared. So b squared has to be 44. We do not need to find the square root of 44. We don't need to find b because we're not really having to graph it. If you need to graph it to find this information, please use the graph. If you need to graph it, please use the graph. So this next one is exactly like A, the one that we just did. We're given the vertices and we're given the foci. So we're going to find our center. What's the center? 8, 0. So is this going to be a horizontal one or a vertical one? What values are changing in the vertices? It's going to be a vertical. And our A value is how far from our center. So A squared, 16. So I'm writing my formula. 16 is going to be in the A squared spot. What goes above it? The y value. So we look at our y, and y is 0 for the center. So we'll put y squared. And then over here we'll have x minus 8 squared. All right, and then the foci, that's going to give us C. So we're going to look at how far away the foci are from the center. So what's my C value? 6. So C squared is 36. We do C squared is A squared plus B squared. So B squared has to be 20. Yes.
How do you know when the flip echelon of like the numerators?
Oh, when y comes first?
Yeah.
When you look at the vertices, which variable is changing? That's the one that comes first. Same thing with the foci. Which variable is changing? That's the one that comes first. All right, the last one is given the center, foci, and then the length of the conjugate axis. And I haven't even said conjugate axis since the very front page. So if you don't remember what it is, then you go look at your notes. Which one is the conjugate axis? Is that A or B? That one's the B. So 2B is 8, meaning B is 4. So B squared is 16. That's what I know so far. I do know my center, but I don't know if X or Y comes first. So what can I use to figure out if X or Y comes first? What do I look at with the foci? Right, so we're going to look at our foci. Which values are changing? So that means the Y is going to come first. This is going to be a vertical kind. So when I write my center, I'm going to use Y minus 2 first, and then X plus 3 in the B side. And we need to find our A, but foci give us C. So how far is the center from the foci? 5. So C is 5. So C squared is 25. And A squared plus B squared equals C squared. It's got to be a 9. Am I missing 5? Okay. Lots of places you can make a silly mistake, so make sure you're asking questions as you're working on it. You've got a lot of time in class to work on this assignment. I also have graph paper to give you. And you'll notice that I put the numbers in a weird order. And the reason why I did that is because originally the thing I handed you with all the assignments on it ended at 23. And then 13 and 14 were on Friday. And I said, no, I'd rather give you 2 more questions today and less questions on Friday. It's the same material. So I put 2 more questions. I just moved them from Friday's assignment to today's assignment. So that's why they're last, but I don't care. You can put them in the right order if you want. Just so you know, don't go off the pink sheet. Go off what's written in this class or what I write on campus, which will be the same.
So